What's up, kids? This is Mr. Carlson, C-Squared Mathematics, Algebra 2.1. Now what we're going to be doing is going through solving quadratic equations, just like what we did yesterday, but not with factoring, but what we call the square root property, so the SRP, and then the completing the square strategy, CTS. Man. Okay, bell work, homework quiz, objective, essential question, and then we're going to get into the lesson. Sounds good? Fantastic. I am ready. Let's go to town. I only have 2 questions for you concerning your bell work, and that will more than likely be on the homework quiz. These are questions from your homework as well. This is a rather difficult one right here. This one was a big one. And then this one right here was a moderate one. Okay? So I'll give you a second to write those down, and then we will get started. So this one I had both of these on the notes. So if you're still like, what the junk? Go back through the notes, and then I will definitely explain it here, there, and I'll also explain it here. But 2 times the charm should be good enough. I noticed a couple things. First of all, this is parentheses, and second of all, I do need to distribute that. This right here is the same thing as saying x squared, in parentheses, minus 6x plus 9. Okay, that's what that is. All right, and then of course the 3 is attached to it. So I am going to just jump there and distribute it out for the sake of time. So that means this is going to be 3x squared, and then minus 18x, and then plus 27, and then of course plus x squared, just chilling right here. After I multiply the 3 and the 9, plus 27 plus x squared equals, this is x squared, this is going to be plus 54x, and then minus 42x. Okay? So when I start seeing this, a couple things happen here. First of all, the x squareds go poofy, and I can actually combine those, so that's what I'm going to do. So I'm going to drop this stuff down real quick. And this becomes, let's actually equal this to 0, and let's subtract this over. This is going to become 12, so 12x equals 0. So this right here is 12x, and then I subtract it over to the other side. Okay, that's so far so good. Now I can combine that junk together. So this is 3x, and then minus 30x, and then plus 27 equals 0. And then, of course, I want to try to get this as simplified as possible. So I am going to divide everything by 3. Now, when I divide everything by 3, this gives me x squared minus 10x, and then plus 9. And now it's very clear what are factors of 9 that somehow, some way add up to 10. Well, this is going to be just x minus 1 and then x minus 9. 9 and 1 multiply together give me 10. Since this sign right here is a positive, that means I look to that sign. That's a negative. Since that's a negative, they both become negative. So what's my final answers? X equals 1 and 9. Perfect. Boom. Done. Okay. Now, this next one, I could use using the quadratic formula. I'm actually not going to. Actually, no, I'll probably just show you real quick. But before I even do that, I need to set it equal to 0, right? Which means I need to subtract this junk over. So this is 4x squared minus 27x, and then minus 7 equals 0. Okay, so that's what that is. Okay. Now that I have this, I could use the quadratic formula, or I could just solve it like the divide and slide. I'm going to solve it using the divide and slide real quick. That's negative 28. Factors of negative 28 that somehow, some way add up to negative 27. So that's just going to be 28 and 1. Which one gets a negative? It needs to be the 28. So that means x minus 28, and then x plus 1 equals 0. Divide by the leading coefficient. This will be negative 7, and then this is just going to be x plus 1/4, because when I actually solve for x, x equals 7, and then negative 1/4. So let's go to Desmos real quick, and I'm going to show you that we get the exact same thing. Okay, so this is factorable, of course. All right, it is factorable, and even if you went through the quadratic formula and you didn't get any bizarre random thing, then that would tell you that it is Yeah, that would tell you that you'd have to solve it by hand. Sorry, if you didn't get any bizarre random thing, that means it's probably factorable. If you got like weird decimals or whatever when you go to this calculator, that means yes, it is probably a radical even. You probably got a radical in there some way, shape, or form, or you had some sort of like weird decimal, weird fraction. Okay, you will sometimes get radicals, just FYI. So you do need to know how to solve it by hand. So what do I do here? Well, my A was 4, and my B was negative 27, and then my C was negative 7. So notice how here are my fractions. So I did get 7, and then negative 0.25 is my fraction, or my decimal, and I could change that. Now, even here, what you could do is change that into a fraction, which is pretty great. That's amazing, right? So you can even change that into the fraction if you wanted to. Now, remember, sometimes it doesn't always work. Okay, sometimes it's too long of a decimal for it to just calculate as to a fraction. It's just automatically going to equal a decimal instead of a fraction. So basically, good rule of thumb is if this button is not there, then that means you must solve it by hand. Especially if it's like a weird decimal here and you get a huge long decimal and that button is not there to press to kind of change it into a fraction, because that's what Math Excel wants, then you must do it by hand. Okay, and again, sometimes you will get what we call a radical in there. And I'll show you what that means right now. Okay, so let's erase this. 5 questions, 25 minutes, open notes. Of course, if you have any questions or partial credit, please let me know and send that to me as soon as possible. Once you're done with the homework quiz, if you're taking the homework quiz, just solve quadratic equations, SRP, square root property, and CTS, completing the square. That's what we're going to be doing today. So how do I solve quadratic equations using the square root property and or by completing the square? So there are 2 techniques. So far, we already have 2 techniques under our belt, quadratic formula and then factoring. So those are the 2 techniques that we already have. The 2 other techniques that we're about to learn is the SRP and then the square root property and then the completing the square. Okay, so let's analyze quadratic equations. We're going to go through the square root property first. Now, this again is my general term formula. This is in standard form. We already know this when we learned the quadratic formula. But here's the point. What if there's no bx term? So what if this junk right here is just straight up poofy? Like what if that I did not have and I just simply had ax squared plus c equals 0? How do I solve it then? Great question, kids. Let's find out. If I have something like that, and of course this is in the similar way, it's just kind of already added to the other side, but it would look something like this. If I had something like that, there's no just regular x term. How do I solve it? Well, we can solve it using what we call the square root property. The square root property tells me this, ready? I can square, instead of factoring necessarily, I can square both sides. But before I square both sides, I have to simplify it so I can get x by itself. So x squared equals, and then this becomes 9. Now what the property tells me, what this property, this square root property tells me, is that I can square both sides. So this becomes x equals plus or minus 3. The squares in the square root goes poofy, and you better believe it's going to be plus or minus 3. Okay, so basically, what's my b term? My b term is 0. So my a term here is 3, my b term is 0, and my c term would be technically negative 27. Okay, because if I added it or subtracted it over to the other side, I would get negative 27. So even if I went to Desmos here and I typed in 3 and I typed in 0 here and I typed in negative 27, I would still get these 2 answers. Look at my solutions up here, right? So I would still get those 2 answers and I would still get them on the graph. Okay, but just honestly, it's way easier to use the square root property instead of just using Desmos. Okay, so let's erase this. That's basically how it is. So let's go through tons of them. Really, only these three. Let's go through these three and then see how we're feeling. First, isolate the x squared part. So that means it's 2x squared. And then equals, when I subtract the 6 over, I get 8. And then divide by 2. So I get x equals 4. X squared equals 4. Square root, x equals plus or minus 2. That's where my parabola, my quadratic equation, crosses the x-axis. Okay, this one. Now here, you may be thinking, oh shoot, let me just FOIL all this out. So x minus 6 and then x minus 6 and then equals 1. And so this is x squared minus 12x. And then this is going to be plus 36 equals 1. And then this is going to be minus, so 35. And then you can go from there. Now, you can do that by all means. That is definitely the one way to an answer. However, an easier way to the answer is simply just square root both sides. Just square root both sides, man. So that means that goes poofy, and now you're just left with x minus 6. This is going to be plus or minus 1. When I add the 6 over, I have two equations. I have x equals plus 1 plus 6, and then I have x equals minus 1 plus 6. So this one equals 5. This one equals 7. Those are my answers. Okay? Really awesome property, right? So this is a really nice property, really simple property. So now let's go through this one. And automatically you should notice one thing that's maybe a little bit odd here. I want you to take a guess. What happens if I actually add this 5 over? Okay, so I get 2x equals negative 200. All right, and if you're still not knowing what's wrong with this, okay, that's fine. Divide by 2, just like normal, all right? So this is x squared equals negative 100. Now watch, ready? What happens when we take the square root of this baby? What happens? Can you do that? Can you take a square root of a negative number? Of course, that side goes poofy, x equals. But can you take a square root of a negative number? Technically, yes, but is it real? No. What is this? We should learn it from 2 weeks ago. What's the square root of 100? Well, that's going to be plus or minus 10. What's the negative? I. That's my final answer. Now, of course, this is going to be in the complex system, whereas these are what we call the real system. Okay, now Desmos only does the real system, which means if I actually plug this in, if I added, watch this, if I added the 205 over, what I'd get is 2x, and then when I added the 205 over, I would just get plus 200. I mean, that's really what I would get, right? I get plus 200. Now, that means my B is 0, but my A is 2, and my C is 200. Now, watch. B is 0, my A is 2, but my C is 200. What's your solutions, guys? The reason why it's undefined is because it's not in the real system. But if I actually zoom out, okay, I do get a graph. And so that's the interesting part. I do get a graph, but notice, is it crossing my x-axis? No. So when we have imaginary numbers, it actually does not cross the x-axis. Hence, no x equals, right? So if it doesn't cross the x-axis, there is no x equals. So you can be sure that whenever a graph does not cross the x-axis, its roots, its values of x equals are imaginary. Okay, they are imaginary. They're not available to us. Okay, so let's move on and erase this, and let's get to the completing the square, or not. Yeah, let's do these. I forgot I had these extra ones. So let's do these extra two, and then we'll get to completing the square. Try this one yourself, and then actually try the second one yourself. Okay, I'm going to pause the video. You try it. Okay, so this is the solution for this question, and it is kind of rather nasty, only because when we simplify this and get this squared by itself, we square roots. I notice I have 20 here, and I actually can't take the square root of 20, which means I need to break this down. And so we kind of do some of our radical calculations here for math. I break this down 5 and 4, this is 2 and 2. So the 2's actually come out, but the 5 just remains underneath my square root, my radical. And of course, it's still plus or minus because whenever I take the square root of something, it is plus or minus something. And then in order to solve for x, all I have to do is subtract 9. Now, the reason why I put the negative 9 in front is because if I did this way, guys, and I did negative 9, oftentimes it's easier to kind of extend that over a little bit, especially on Math Excel, and you're in a quick hurry and then you hit equals, and that's just wrong. So what I normally do is I normally just put negative 9 or any of my constant terms in front of my actual quadratics, okay? So the next one, let's try this. And once you square root, you notice one thing, of course, that should be imaginary. So I have x plus 6 equals. What's the square root of 49? Well, that's going to be plus or minus 7. And then since I have a negative, I'm going to tag on an I. Now all I have to do is just subtract by 6. So subtract 6, and I have plus or minus 7i. Now, Math Excel will more than likely ask you to do two separate equations for this. So negative 6 plus 7i, and then x equals negative 6 minus 7i. So most likely they'll ask for both. They may even ask for both over here and say negative 9 plus 2 radical 5, and then comma, negative 9 minus 2 radical 5. They may even ask for that. I'm not sure, so I can't remember, but just know that you can separate them into two separate values. Okay? You can separate them in two separate values. All right. Let's erase and let's continue. So completing the square. So the steps. What is completing the square? Well, the term completing the square is derived basically by completing the square property. Now, when I say completing the square, the reason why it's called a square is because of the square root and also the squared exponent on the quadratic. Now, many of you may say, like, why is it squared? Like, it's not like squared. Like, it's not like a square, an actual square, where you find like you have four sides. So how is that possible? Well, it's not four sides. Sure, it's a parabola, but instead you do have the area of a square being x squared, something squared, right? And so essentially, I'm not going to show it here on time, but the proof of completing the square is rather brilliant. And actually, the quadratic formula, why we have the quadratic formula, is because of completing the square. If you complete the square, that means you get the quadratic formula. That's why the formula works. So in other words, if the quadratic formula always works and that came from the completing the square, that means that the completing the square also always works. Okay, always works. It will always give you a right answer. Even imaginary, radical, it doesn't matter. It will give you your solutions. Now, the reason why students don't really like completing the square is because it can get very complicated. Okay, so I'm going to try to do this as best of my ability. First things first, I want to move the constant to the right side. I'm going to show you what that is. Divide everything by the LC, take half of b, square it, and then add it to both sides. This, leave a couple of like spaces here because this right here is the most important step and the hardest step, and I'm going to put a little formula there. Okay, and then we want to factor the perfect square trinomial because what we're going to be doing is really creating a perfect square trinomial, creating a square, okay? But abstractly, not like actually visually, but we'll be creating a square abstractly using our math. And what that square is a perfect square trinomial. And then we're going to use that by solving, use the square root property to solve for my x values. That is my small formula that I have right there. It's just b, my b term. I square that and add it to both sides. So take half of b, I square that and add it to both sides. So I'm given this one right here. So very simple quadratic equation, not too terrible. So first things first, I want to move the constant to the right. Now the cool thing is it's already to the right because it's got us. Good job, thank you. And so now I want to divide everything by the leading coefficient. Well, my leading coefficient is 1. So if my leading coefficient is just 1, do I need to divide everything by 1? No. So that's also good. Now I want to take half of b. So what's my b value here? Well, my b value is 6. So what's half of b? Half of b is 6 all over 2 and then squared, which is 3 squared, which is 9. Okay? Now watch what I'm about to do here. When I do this, what I do is I take x squared plus 6x plus blank equals 5. And what I do to one side, I must do to the other. So watch what I'm about to do here. The reason why I take this half of b is because I take this 9 and I literally move it in those spaces. That's why I needed to take half of it. So that becomes 9. That becomes 9. Now notice how I'm kind of balancing the equation here so it works. Like I could totally do it. Now, originally this is not a perfect square. But since now what I'm doing is I'm creating the square so that this can actually be factored as a perfect square trinomial, which it is. I can now factor this. What's that perfect square trinomial? X and then plus 3 squared. Now, if you're struggling with that, if you're like, holy junk, how'd you get that? Well, really, the first things first, you have to realize that the x squared and the 9 are now perfect squares. So I square root. Remember, on Monday, we went through factoring review 2 days ago, 2 lessons ago. And that's how we factored this. But also, if you're wondering where I get the 3, I get the 3 just right here. So whatever that in parentheses is, whatever this right here is, that's what that is right here, the plus 3. Okay? And I just take the sign of that as well. So if that was negative, I would take the negative here. If that was positive, I'd take the positive here. So that is a positive 3. Now on the other side, this is going to be 14. And now what I can do is I can take the square root property. So the square root property, oh, sorry, this is going to be negative 5. So not 14. My bad. I didn't even put the negative 5. Whoopsie. So this is 4. I take the square root property, that goes poofy. This becomes x plus 3 equals square root of 4 plus or minus 2. Now what this tells me right here, because I got like straight up like numbers, whole numbers, not fractions or any radical thing like that. Since I got whole numbers, what this tells me is that it's factorable. Like this right here is actually factorable and I don't need to do completing the square. I'm going to show you that in a little bit. Let's finish it. This is going to be negative 3 plus or minus 2. So that means my solutions are x equals negative 3 plus 2, x equals negative 3 minus 2. Gross. Minus 2. So that means this is x equals negative 1 and negative 5. Right? Negative 1 and 5. Negative 1, negative 5. My handwriting is not being so great today. Okay, now can this be factored? Yes. Okay, so x squared plus 6x plus 5. Factors of 5 that somehow, some way add up to 6, 5 and 1. Okay, so I really did not need to do this way, but it does show you that it works either way, just like the quadratic formula. The quadratic formula always works just like the completing the square, okay? So let's go through a next one, a little bit chunkier one. By chunkier, I mean a little bit more difficult. Okay, this question is going to give you some fractions involved, but it's still going to be an awesome experience. Now, let's solve it, shall we? Take half, because it's already moved to the right side, take half of 7. Now, this is rather intense, because what's half of 7? I mean, that's a gross looking thing, right? Who wants to take half of 7? And I want to square that. What does that mean? This means it's going to be 49 all over 4, because the squared goes to the 7 and to the 2. So what does this mean? I use my basic template. Oh man, this just looks gross. I can't do it. So this is going to be minus, and then this is going to be plus blank equals negative 12 plus blank. What is that blank? What goes in that spot? 49 all over 4. So 49 all over 4, and it's kind of gross, and this is why students mainly don't like doing this. And then what we want to do is, after we did that, which we did, I want to factor the perfect square trinomial. So I'm going to take x, and then remember, whatever's in here is the thing that I put right there. Okay, so what is that? It's just going to be minus 7 all over 2, and then I want to square that. Equals. Now this is really nasty, okay? So buckle up. I get this over 1, so this is negative 12 all over 1 plus 49 all over 4. Now how can I simplify this? Well, times 4 gives me 4, times 4 gives me negative 48. So this equals 1 all over 4. Well, that's not bad. Negative 48 plus 49 gives me 1, 4 and 4, so it's just 4. Now, when I get to this step, because I just bring it down, I then perform the square root property. Okay, so that's what I'm going to do now. Is perform the square root property. That goes poofy. This now becomes x minus 7 all over 2. And then this equals plus or minus. This right here is a straight up perfect square in both the numerator and denominator. So 1 half. All I have to do is just now add the 7 over. I'm going to move my face up there. So I add the 7 over. This equals, I have 7 halves plus 1 half. And then I also have x equals, this is my first one, this is my second one. And I also have 7 halves minus 1 half. What is 7 plus 1? Well, 7 plus 1 is 8 all over 2, which equals 4. Well, that's nice. Okay, and you know what that tells you? Since that's a great number, this also tells you it was factorable from the very beginning. Isn't that great? It was factorable from the very beginning. Okay, and then this right here gives me 6 all over 2, which gives me 3. Definitely factorable. How is that? X squared minus 7 and then plus 12. Factors of 12 that somehow, some way add up to 7, especially if they're both negative, negative 3 and 4. And then I change the sign, 4 and 3. So these are my answers. X equals 4 and 3 down here at the bottom. Those are my answers. Those are my answers. Those are my answers. But you could have definitely solved this using factoring or quadratic. Most of the time, you probably won't solve it using the completing the square method. I get that. But sometimes this completing the square method actually does help. So I'm going to erase this, and I'm going to get to one of our last examples. Actually, it is on our last example. Yay. So what is this? This is this question. Now, is this factorable? Let's actually ask that question right away, right? Let's do that. That's the question you actually should be asking right away, no matter what, always, always. But is this factorable? And at first glance, you may say, yeah, it is. Okay, factors of 5 is just 5 and 1. So if we look at this, x and then 5 and 1. Now notice how that's a negative and that's a negative. They can't both be negative, because if I foiled it out, okay, if I foiled it out, that would work if this was a positive, but it's not, because negative 5 times a negative 1 does not give me a negative 1, a negative 5, it gives me a positive 5. So that doesn't work. But that's the only way it could work, because if that was positive, that wouldn't give me 6. And if this was positive and that was negative, that still wouldn't give me 6. So that means, what are we supposed to do? Great question, kids. We can use completing the square, or we can use the quadratic formula. I'm going to show you completing the square. Okay, so I've given you pretty light ones because they've always been moved to the right, and you've never really needed to divide by the leading coefficient here. So I've given you pretty easy ones, but you will on your homework have some harder ones. But always check to see if it's factorable. That's what you should always do. What's half of 6? And then squared, that's going to be -3, and then squared, so 9. So my basic template is x squared minus 6x plus blank equals 5, and then plus blank. What's that blank? That blank is 9. Okay, so that is my perfect square trinomial. So this is going to be -3 squared. Remember, you can just take that number, and that's going to be the -3. And this equals 14. Now, when I square root and square root, the interesting part that you see is you get radical 14, plus or minus radical 14 to be exact. Now, the problem with this is that 14 you cannot break down. It's just 7 and 2. So you can't break that down anymore. So you're just going to add the 3 over. So x equals 3 plus or minus radical 14. And this is my final answer. If you plug this into Desmos, okay, so x squared minus 6x minus 5. If I plug that into Desmos, watch what happens. X squared, so 1 minus 6, and then minus 5. Okay, you get some strange fractions, I guess, but primarily it's a radical. Okay, so if I go home here, okay, these values are just really odd values. And again, remember, good rule of thumb is if you don't have a button here, if you don't have a button to kind of change those decimals into a fraction, more than likely it's a radical or something else. If it was imaginary, that would mean it's undefined. So if you don't have buttons here, that means it's either a really strange fraction or it's straight up radicals. Okay? And so since we had radicals, of course, that makes sense. Weird decimals, it's going to be radicals. Okay? The plus and the minus. Awesome. So here is a general strategy on basically what to do when you're solving quadratics. So the factoring in the quadratic formula is not the only method for solving quadratic equations. We went through 2 other methods right now. We went through the square root property, and also we went through the completing the square. Okay? So what does that give us? Factoring. Factoring only works when the expression can indeed be factored. Right? You always want to try this first. First and foremost, if it can be factored, you want to try to factor it. The quadratic formula. Now, that always does work, even if it could be factored. So when in doubt, just use the quadratic formula. The square root property. It is a nice shortcut, but it doesn't always work. It only works if you don't have a bx term, and so that's really nice. Okay? Or if it's already like x minus 6 in parentheses squared, something like that. And then completing the square. This also always works, but it's also not the best method for solving quadratics, but just a good method to know in other areas of mathematics, such as pre-calculus, if you take pre-calculus with me. Okay? So what did we learn? We learned some good things. We learned how to solve quadratic equations by the square root property, and then we learned completing the square. Those are primarily the only things that we learned. So make sure you email me with questions today. If you don't want to take the homework quiz, that's fine. Tomorrow we're going to be doing a Desmos activity and be reviewing for your Solve Quadratics quiz. Until next time, make sure you do your homework on Math Excel, solve quadratics, equations, SRP, and CTS. And this is C Squared Mathematics. See you guys later.